In this video, we'll look at how to graph a rational function when it has a hole. You might notice it has a hole yet, but if you don't, I'm going to show you how we know it has a hole. That is, whenever you're looking at rational functions, you should always try and factor it. And in particular, this numerator is divisible by 3, both terms. You pull a 3 out of the numerator, you get 3 times, what's 6x divided by 3? 2x. What's 9 divided by 3? 3. And look at that. You get 2x plus 3 and another 2x plus 3 on opposite sides of this fraction. That's the definition of whole. A whole is when you have a factor on the top and a factor on the bottom. That factor has to include an x. Or another way to think about it is if you subbed in a number here, in particular negative 3 over 2, you would get 0 over 0. That's the definition of whole. So this factor we can cancel out with this factor. Again, it's like this is in brackets. And what we're left is the function equals 3, but comma, we have to keep this restriction around of what x couldn't be. I said a moment ago the whole is at negative 3 over 2. How did I know that? You can show a little work on the side to find out where that whole is. I mean, it's clearly at wherever this bracket makes it, 0. So we're going to check. What makes 2x plus 3 0? What would you have to sub in for x to make this and this both 0? Well, just solve this. What makes 2x plus 3 0? Subtract 3 both sides. You get 2x equals negative 3. And then how do you get x by itself? Divide by 2. And so x equals negative 3 over 2. That's how I knew. I just did that in my head and knew there's going to be a hole there. So when you write this equation and factor it and cancel out, you need to say, look, I've reduced it. This 3 stays here, but comma, there's a hole when x cannot equal negative 3 over 2. So how do you graph that? Well, it's a piece of cake. Let's make our x-axis and our y-axis. Don't forget to put arrows. Label the axes. This function is just now equals 3, which means whatever x you pick, you get 3. X is 1, 3. X is 2, 3. X is 3, 3. You get a flat line at x equals 3. I'm going to take my ruler, make a flat line at x equals 3. But one problem. There's one exception, which is at negative 3 over 2, which is negative 1.5. So here's maybe negative 1. Here's maybe negative 2. At negative 1.5, you got to leave a space, an open dot, which says, hey, right here, there's a hole. This is the same function. Oh, I'm having a little trouble graphing it there. This is the same function that it was given to us originally, except we've reduced it and said, look, it's a flat line, but there's a hole. I'm not super happy with how my line turned out. A little trouble drawing it there, but it looks good now, I think, and I'm going to call this f at x. F at x is a flat line at x equals 3 with a hole at negative 1.5, and that hole is symbolized by an open dot. That's it. That's how you graph a rational function with a hole.